Now on Nova. Take a thrill ride into a world stranger than science fiction, where you play the game by breaking some rules, where a new view of the universe pushes you beyond the limits of your wildest imagination. This is the world of string theory, a way of describing every force and all matter, from an atom to Earth to the end of the galaxies, from the birth of time to its final tick, in a single theory, a theory of everything. Our guide to this brave new world is Brian Greene, the best-selling author and physicist.
And no matter how many times I come here, I never seem to get used to it.
Can he help us solve the greatest puzzle of modern physics? That our understanding of the universe is based on two sets of laws that don't agree. Resolving that contradiction eluded even Einstein, who made it his final quest. After decades, we may finally be on the verge of a breakthrough. The solution is strings. Tiny bits of energy vibrating like the strings on a cello. A cosmic symphony at the heart of all reality. But it comes at a price. Parallel universes and 11 dimensions, most of which you've never seen.
We really may live in a universe with more dimensions than meet the eye.
People who've said that there are extra dimensions of space have been labeled crackpots or people who are bananas.
A mirage of science and mathematics? Or the ultimate theory of everything?
If string theory fails to provide a testable prediction, then nobody should believe it.
Is that a theory of physics or a philosophy?
One thing that is certain is that string theory is already showing us that the universe may be a lot stranger than any of us ever imagined.
Coming up tonight.
We accidentally discovered string theory.
The humble beginnings of a revolutionary idea.
I was completely convinced it was going to say Susskind is the next Einstein.
This seemed crazy to people.
I was depressed, I was unhappy. The result was I went home and got drunk.
Obsession drives scientists to pursue the holy grail of physics. But are they ready for what they discover? Step into the bizarre world of the elegant universe right now.
Major funding for NOVA is provided by the Park Foundation.
Science. It's given us the framework to help make wireless communications clear. Sprint is proud to support NOVA.
We see an inventor. At Microsoft, your potential inspires us to create software that helps you reach it. Your potential, our passion.
Funding for the Elegant Universe is provided by the Alfred P. Sloan Foundation to enhance public understanding of science and technology. And by the National Science Foundation, America's investment in the future. Additional funding is provided by and by the George D. Smith Fund and the U.S. Department of Energy, fostering science and security. Major funding for NOVA is also provided by the Corporation for Public Broadcasting and viewers like you. Thank you.
It's a little-known secret, but for more than half a century, a dark cloud has been looming over modern science.
Here's the problem. Our understanding of the universe is based on two separate theories. One is Einstein's general theory of relativity.
That's a way of understanding the biggest things in the universe, things like stars and galaxies. But the littlest things in the universe, atoms and subatomic particles, play by an entirely different set of rules called quantum mechanics.
These two sets of rules are each incredibly accurate in their own domain, but whenever we try to combine them to solve some of the deepest mysteries in the universe, disaster strikes.
Take the beginning of the universe, the Big Bang.
At that instant, a tiny nugget erupted violently. Over the next 14 billion years, the universe expanded and cooled into the stars, galaxies, and planets we see today.
But if we run the cosmic film in reverse, everything that's now rushing apart comes back together. So the universe gets smaller, hotter, and denser as we head back to the beginning of time.
As we reach the Big Bang, when the universe was both enormously heavy and incredibly tiny, our projector jams. Our two laws of physics, when combined, break down.
But what if we could unite quantum mechanics and general relativity and see the cosmic film in its entirety? Well, a new set of ideas, called string theory, may be able to do that. And if it's right, it would be one of the biggest blockbusters in the history of science.
Someday, string theory may be able to explain all of nature, from the tiniest bits of matter to the farthest reaches of the cosmos, using just one single ingredient: tiny, vibrating strands of energy called strings.
But why do we have to rewrite the laws of physics to accomplish this? Why does it matter if the two laws that we have are incompatible? Well, you can think of it like this. Imagine you lived in a city ruled not by one set of traffic laws, but by two separate sets of laws that conflicted with each other.
As you can see, it would be pretty confusing.
What the heck are you doing? To understand this place, you'd need to find a way to put these two conflicting sets of laws together into one all-encompassing set that makes sense.
We work on the assumption that there is a theory out there, and it's our job, if we're sufficiently smart and sufficiently industrious, to figure out what it is.
We don't have a guarantee. It isn't written in the stars that we're going to succeed. But in the end, we hope we will have a single theory that governs everything.
But before we can find that theory, we need to take a fantastic journey to see why the two sets of laws we have conflict with each other. And the first stop on this strange trip is the realm of very large objects.
To describe the universe on large scales, we use one set of laws, Einstein's general theory of relativity, and that's a theory of how gravity works. General relativity pictures space as sort of like a trampoline, a smooth fabric that heavy objects like stars and planets can warp and stretch. Now, according to the theory, these warps and curves create what we feel as gravity.
That is, the gravitational pull that keeps the Earth in orbit around the Sun is really nothing more than our planet following the curves and contours that the Sun creates in the spatial fabric. But the smooth, gently curving image of space predicted by the laws of general relativity is not the whole story.